Okay, so we are now looking at one of the topics in GBS 650, which is production and operation management. And this is inventory management. So inventory means stock. You can have the stock of bananas, the stock of potatoes, and a number of stocks, potatoes, bananas, oranges, and all that. So that is the meaning of stock. Now we get into what the advantages of keeping the stock. So the first advantage of keeping stock is that you keep stock so that the firm does not incur every time ordering cost. Then the acquisition cost and the stock out cost. You need to have stock every time that you need to maintain the customer's goodwill, because when the customers know that you don't have stock at the time, they'll stop coming. So you need to have stock every time to retain the customers. So that is one the advantage of stock keeping. Then getting down to the disadvantage of keeping stock, the firm will incur continuous carrying cost. This carrying cost is also called the holding cost, where we are paying for the warehousing salaries and wages for those who are manning the stock in the warehouse. And also inventory needs to be insured. So you need to pay the insurance fee of the stock. We have to also now getting down to the other disadvantage of stock keeping, where we say inventory may be damaged or spoiled. This is about the disadvantages. There may be a number of them, because also you need to pay for this floor space charge related to warehousing activities. This is just about the other disadvantage of keeping stock. So there's a floor space charge when you're keeping stock in the warehouse, and especially the people who are manning the stock, you need to pay them. So it becomes an expense on stock keeping. Bananas may go bad. Tomatoes, if they are very ripe, they may go bad. So they may be damaged or stolen or spoiled or be damaged by fire. All right, there are 3 inventory models. There is the model 1 purchasing model, the model 2, which is the production model, model 3, which is the discount model. So they can only give us the discount when you are buying. So model 1 and model 3 formulas are the same, because the purchasing model we are buying, and then the other one we are talking about, the model 3, also relates to buying, except that for model number 3, it has a range of ordering policy. So this one has a range of ordering policy. So this is about the model 3. Now, according to the question we're looking at as at now in inventory management, it has to do with model 2, which is the production model. And this one is only this one here, question 4. It has to do with the production model. So under this one, there are formulas that are involved as we look at the production model among the 3 models that are there. Okay, among the 3 models. So there is under production. So we will look at this model 2 to do with production for now, according to the question that is coming, that the lecturer or the examiner likes. So it has to do with production. So there are formulas that are invoked as we look at the production model. So the first formula here, it is called economic lot size. So formula number 1 is called economic lot size. Lot size simply means production size, which is equal to 2ds over C, then multiply by P over P minus D. Okay, this is only the formula that we need to use. Now, D is our annual demand. So under D, this is our annual demand. Then we have the other one, which is our S, is called setup cost per setup. So setup cost per setup. Then we have the other one, which is P is our daily production. Of course, the small d, so this daily production, we can get it from annual production. So annual production is capital P over days of the year. This is how we get the daily production. So annual production over days. Then the small d is daily demand. So daily demand, which should be equal to annual demand, capital D, over days of the year. So it's easy. Annual demand over days of the year. Over days of the year. So this is about the formula to go for as we look at. This one is called economic load size. Economic load size. Now, this economic load size, it's also called the production size. So economic load size is also called production size. So on this one, this is about what goes on. Okay, so this is a breakdown. Then C is a carrying cost or holding cost. Carrying cost or holding cost per year. Carrying cost or holding cost per unit per year. So this is about what we have on this one. Holding cost, this C can be C or it can be H in other books. So this is a very important formula that will lead us to the second formula, which is called, so this is how many units of the commodity can we produce. We are no longer interested in buying because we want to be independent. Now we shouldn't be buying every time from our suppliers. We need to be producing our own goods. So we have to migrate from buying, and this is why we're looking at model 2. So this one is called inventory management model number 2. So this is model 2 as we look at management of inventory. It's very important to manage inventory because we need to know who are misusing our stock in an organization. All right. So this is what we are having on this one. So we now look at the second formula. So the second formula now we get into formula number 2 under the same model, which is called number of production runs. N is number of production runs, which is equal to D over Q. Now this Q is the same as economic load size. the one you found in the first place. This is called also quantity, economic production size. It's the same as Q. So we're getting down to this number of production runs, number of production runs. Okay, so now after this, we now get into the other one, where we look at number 3, which is length of producing the batch, length of production run. So length of production run, the formula is equal to Q over P. So this Q is the same as the economic loads that we found in the first place. So what is very important in this inventory management is just to get the first question correct, which is on economic load size. And then all other questions coming down will not be an issue, because the first answer is correct that we need to substitute in the other questions coming. Then getting down to the other one, the other formula here, which is cycle time. So cycle time is simply the time taken between production runs. So this is just the time taken between production runs. So between production runs. So under this cycle time, the formula here is equal to cycle time, which is CT, is equal to Q over D, then multiplied by the days of the year. Days of the year. Okay, we're getting down now to the other one, where we are looking at reorder point. So under this, our reorder point, this is formula number 5. Now we're getting down to okay, so we have reorder point. Okay, so the formula number 5 for reorder point. So we are going to have is equal to expected demand during lead time, then plus the safety stock. So expected demand during lead time, then plus the safety stock. So our OP is equal to expected demand during lead time, then plus the safety stock. So this is on a reorder point. This is the point at which you need to order the units of the commodity again. And you don't have to wait for mini mill to finish for you to make an order. So now, the expected demand during, if you have ordered a bag of mini mill like this, the bin is full. Then when mini mill comes to this level, this is our reorder point. So you tell the people at home to say, when mini mill reaches this level, because we're almost running out of it, they should inform you so that you order again so that you can fill up the bin. So our expected demand during lead time is equal to daily demand. So daily demand. Then you multiply this one, daily demand, by LT. LT is the lead time. So this is on expected demand during lead time. Then on the S safety stock, so our safety stock is a buffer stock kept to cushion on demand for security reasons, because you don't necessarily need to finish out of whatever it is that you have harvested. In times of hard times, in times of tough times, you need to make sure that you use whatever you've kept as safety stock. So it's Z value, which is calculated, multiplied by the standard deviation of demand. So this one is called standard deviation of demand. So we're getting this as standard deviation of demand. Okay, so this is what goes on this loader point. So now we're getting down to the other formula here that we need to look at, which has to do with maximum. So here we can combine these two. So it's D times LT for the expected demand during lead time. So daily demand is a small d. Then here, safety stock is Z value, then multiplied by the standard deviation of demand. This is how we get to the reorder point. Then we move on to the other one where we look at the maximum inventory level. So maximum inventory level, that's 0.6. So maximum inventory. Okay, so on maximum inventory is actually equal to P minus D, then multiplied by Q over P. Then if there is a safety stock, we are going to put plus the safety stock. Okay, so this is on the aspect of what we are looking at. Okay, so we have to look at this one. Now, when you get into stock taking, the total stocking cost, TSC is the total stocking cost, is actually equal to Q over 2, then P minus D over P by C plus D over Q on S. This is on total stocking cost formula. The Q is what we found as our economic lot size in the first formula. So the Q is the economic lot size, which would have gotten it from the first part of the question here, from the formula sheet here that we have. That is, if this is wrong in inventory management that I overemphasize, you may find it very, very difficult to get other questions coming down correct, because that's the cardinal point, cardinal part that we need to go for. And then the last formula here is on our TMC, which is total material cost. TMC is called total material cost. TSC is total stocking cost. So it is just actually the Q over 2, the same ones, build up, just this, then P minus D over P by C, then plus D over Q on S, then plus AC by D. All right, so now this is total material cost. Now the total stocking cost due to safety stock. So there's another one here where they ask us to find the total stocking cost due to the safety stock. So under this one is actually formula is the just a little bit of a build up of this one. So this is without safety, the first one. So here due to safety, it will just be Q over 2 P minus D over P by C, then plus D over Q multiplied by S, then plus carrying cost. So carrying cost, then we multiply this one by the safety stock. So this is about what goes on as we look at the total stocking cost due to the safety stock. So we need to use these formulas. So these are the formulas we need to use as we're looking at inventory management model 2. Now, straight away, we can get into an example. We are applying these formulas based on the examples that are there. So the most important thing to understand are these formulas, especially the first part of the question is what is very, very important. All right, so that we can now sort out anything else that we need to. All right, so we have this question now that we can look at. So a book world, the publishing company, produces the books for retail market, and the demand for the current book is expected to occur at a constant rate of 7,500. That's our D, is 7,500. That's our annual demand. So that's what we need to look at as much as we apply those formulas that are listed. And then the cost of one copy of the book, which is acquisition cost per unit, which is the unit price. AC is acquisition cost per unit is $27.50. That is 27.5 dollars. The holding cost is based on, so carrying cost is a percentage of acquisition cost. So carrying cost, you just find it is 18 over 100 multiplied by acquisition cost. So it must one multiplied by 27.5. So we can find our carrying cost straight away, which is equal to $4.95. $4.95. Then from here, we can build up a little bit and now find, we continue here, the production setup, which is our S, our setup cost is $550. We are setting up for production in terms of you clean up the equipment, clean up the bottles if you're producing soft drinks, and clean up the environment and every other things before you set up things for production. Then the annual production has been given as 21,000, which is our capital P. Our P is 21,000 from that question. So 21,000 copies. So our P is 21,000. So meaning we can find from there, we can find our daily production. So a small p is equal to 21,000. Then we check how many days they were operating. We divide by. So they were operating 250 days. So you can find the daily production from there. As we have been given the annual production, so we can find the daily production. So meaning if you are working 250 days in a year, it means that the other days are not working because the year has 365 days. So meaning they have off days on other days that are not supposed to work. All right, so now we divide by 250. We are getting the value of 84. And then from here, we can find our daily demand, which is annual demand divided by the same days. So meaning our annual demand has been given us, in this one is 7,500. So 7,500, we divide this one by 250 days. So this is clearly an indicator that it's a production model because we have the number of days, and of course, we have the annual production. So here we need to know that we are in production. All right, so we have that information, which is very important, and then we just need to substitute. Then here they are saying the lead time between production runs, the time taken between when somebody has placed an order that we need to produce the goods and the time that he receives that order is 12 days. And here we are assume that the company is willing to tolerate a one stock out per year, meaning here it means that for whatever they have produced, there's a probability that one out of what they have produced will not be there. Assume the company is willing to tolerate one stock out per year, meaning for the number of production runs that they are producing, the number of production runs, one out of those production runs, they may not produce. There's a probability that one out of those times that they're producing, they may not produce. And that the standard deviation of demand is 75, meaning that this is the standard deviation of demand is 75. So this is an indicator of anything else, a summary of this important question that the examiner likes. So we need to just understand as we go through. So now the first one is saying what's the minimum cost load production load. So here we have everything else. Our carrying cost is a percentage of acquisition cost. So this one is called acquisition cost. Okay, so we have gotten that. Then just substituting in this economic lot size formula, which already been given, is 2 is constant, ds over c multiplied by p over p minus d. The square root of this is the same as this economic. This is not supposed to be order. It's economic lot size because we mentioned economic production lot. So it is 2 ds multiplied by p is the same. When we combine this denominator can multiply with this one. It's okay because it's multiplication. So we can substitute here whatever we have, and we are getting 1,610.15 of substituting the demand. There's a multiplication. All these we are multiplying. There's multiplication there. So meaning we are getting our economic lot size as the 1,610.15 Similarly, if we can go step by step, for those may need to understand thoroughly, we may go this way, where we now simply say everything else has been given on this one. So we need to say the first one on our economic lot size. We simply have to say it is our 2ds over C multiplied by P over P minus D. So from here, we can say our economic lot size, if this is correct, then everything will be correct. So 2 multiplied by 7,500. Then from the breakdown, we are multiplying by S, which is a 550. Then over our carrying cost has already been computed as 4.95. Then multiplied by P is 84. Then over 84 minus 30. So after applying this formula correctly, multiplying one by one, step by step, our economic lot size is 1,610.15 copies. So this is the first answer that after using a calculator nicely, you should get this answer here by substituting that. From these breakdowns are there. Then number 2, number of production runs from the question says number of production runs. We have to get, so from here, number of production runs, so that's number 2. It is just the D over Q. So the D over Q is annual demand, which is 7,500. So this is number 2, okay? So it is just the D over Q. That is how many times are we going to produce to meet the annual demand. So number of production runs, we simply say N is equal to D over ELS. At the time we are producing 1,610.15. Now to meet the annual demand of 7,500, how many times are we going to produce? So at the time we are producing, this is the same as Q, the ELS, 1,610.15. As we divide this, we are getting 4.66 runs. So this is what we have, okay, on the second one. Okay, so now from here we get into the other one, cycle time. If we get to cycle time, number 3, cycle time is actually the time between production runs. So our cycle time is equal to Q over D multiplied by the days. So we know our Q is 1,610.15 divided by the 75, then multiplied by the 250 days that are there. So this is about how we get to the cycle time. So our cycle time, okay, so our cycle time there will give us 53.67 days, 53.67. So every after 53.67 days, we need to actually produce. So the time between production runs is 53.6. All right, then, so we get into the other one here. So the cycle time 53.67 is number 3. because of the formula sheets that are there. Some of the formulas are given. Length of producing, that is length of production run. Number 4 is equal to Q over P. The Q is the one we found, which is the ELS. That is the Q over the daily production. So this one is 10.15, then over 84. So we are getting 19.17. Time taken to produce a batch. One batch, we are simply saying it's 19.17 days. Getting down to maximum inventory level, the formula is here. Maximum inventory level, we have there's a formula here for maximum inventory, which is this one, P minus D multiplied by Q over P plus the safety stock. The P we know is 84. So under that one, Q is we know is the economic load size. P is our daily production. And then the safety stock formula is actually given here. Safety stock is Z value multiplied by standard deviation of demand multiplied by the square root of lead time. Okay, so now under this one, getting down to maximum inventory, okay, max inventory is actually going to be P minus D. Then we multiply, so P minus D multiplied by Q over P, then plus the safety stock. So plus the safety stock. This is how we get to the maximum inventory. So our maximum inventory is actually going to be, our P is 84, then minus the 30, which we know as our daily demand from the computation, multiplied by this Q is same as economic load size, the one we found in the first question, which is 1610.15 over our P is 284. Now the issue is we need to find the safety stock. So our safety stock, okay, so safety stock is actually going to be our Z value. Okay, so Z value. So we have the Z value, then multiplied by the standard deviation of demand. So our probability of stock out, probability of stock out in this case is actually going to give us 1 over number of production runs. The one is given in the question. We are informed here, we have been informed that 1 out of how many runs they may be stock out. From here, they are simply saying the company is willing to tolerate 1 stock out per year. 1 stock out per year. So meaning that 1 stock out per year, the number of production runs are 4.66. So 1 out of this is our probability of stock out. We are able to produce number of production runs. We need to produce at least 4 times a year, but 1, they are willing to tolerate 1 stock out. So probability of stock out is just 1 out of that. So getting down to this probability, it is 1 out of 4.66. This is the probability they are willing that they have stock out. 1 divided by 4.66 is 0.2146. And then getting to the normal tables or cumulative table, the Z value, we can check for this probability. We need to find the Z value corresponding to this probability, which is giving us the 0.79. You can check for this from the standard tables, or even if you are using the cumulative table, meaning for the cumulative table, we need to check for probability of 0.7854, meaning that what we are doing here is that we are subtracting 1, the probability to be 1 minus the 0.2146 using the cumulative probability table. So this is for cumulative, and we want to find the Z value. So cumulative, we have to check for this cumulative probability. So meaning is the 1 minus 0.2146. So it was just the same. We are getting the 0.7854. So whichever way we are using the table to get the Z value, you are getting this amount, this value from the table. So just a matter of going through the normal Z tables or the cumulative Z tables. For cumulative table, we use the P of this. For the non-cumulative, so this is non-cumulative table, the 0. You just locate for the Z value corresponding to this one. So the safety stock here will be a Z value 0.79, then multiplied by the standard deviation of demand, which is 12. That has been indicated here in the question. Then we can get to the final answer here for a maximum inventory. This is one thing. This one is one thing. Then we can find the maximum inventory level there. So that will be the difference between here is 54. So 54, then you multiply 54 by 161, that's 1610.15 divided by 84. Then plus 0.79 by 12. It's giving us the amount of the safety stock that we need for this one. Okay, so meaning that we have maximum inventory as the 0. Okay, we have the standard deviation of demand is 75. Okay, so we have the standard deviation of demand is 75 there. The real time, the one which is 12. Okay, so we need to incorporate that. So this is 75, the standard deviation of demand, which is 75. This is 0.79. Then you multiply this one by 75 to get the safety stock value. So this is 75. Then when we aggregate this to find the the amount of maximum inventory level, we need to multiply those and then get the answer. So we are getting 1094.3, so 0.3464. So this is what we have on maximum inventory level. So we need to combine, due to safety stock, the value is Z value multiplied by, there's a probability of stock out of how many production runs we are having in a year. So meaning 1 out of 4.66 we may not produce. This is about how we are getting this, and then taking this value from the Z tables on cumulative table, the normal tables, we are getting the 0.79 multiplying by the standard deviation of demand, which is given 75 in the question. We are getting maximum inventory as 1094.3464. So this is where these answers are coming from. So like here, maximum inventory level, the safety stock level has been found as just 0.79 by 75 using the Z value. The probability of stock out is 0.1 out of the runs. The maximum inventory is 1094.35. Then getting down to the other question where I'm saying so this one is done, this one is done, this one. So we are getting down to the order point. The order point, we need to know a time at which we can order again or produce again. So is actually equal to, so our order point, our ROP is actually equal to expected demand during lead time, then plus the safety stock, which is the buffer stock kept for security reasons. And then under this one, we are simply saying this is daily demand multiplied by lead time on the order point aspect. Then the safety stock formula is Z value multiplied by the standard deviation of demand. So this is aspect of our order point. So our order point is actually going to be daily demand is 30. Our lead time is 12 from the question. So the 12 for lead time has been indicated here as 12 days. The lead time for the production is 12 days. So that's what we're using now. And then we are simply daily demand multiplied. So expected demand during the lead time is that amount. Then plus the Z value, we have already calculated 0.10 from the table, 79 multiplied by 75 on the aspect of safety stock. So meaning here we are going to have 30 by 12, then which is 360, then plus the other aspect there, which is 59.25. So we can aggregate these ones and you're getting 419.25. That's our order point, 419.25 is our order point. This is on part F of the problem that is given here. So you go to a safety stock has already been, we have already found it. There's no need for G. Our safety stock they're asking for is just the one we are from finding here. So our safety stock is actually going to be our Z value that we know, then multiply by the standard deviation of demand. So our Z value we know is the 0.79 we can get from the tables, multiplied by 75, So it's just 59.25 is our safety stock. Okay, so this is on G. Then we're getting down to the last question, where we want to find now the total stocking cost. Now this one should be due to safety, due to safety stock, because the safety stock is there, we have already calculated, unless the safety stock was not there. So due to safety stock, we need to calculate that. All right, so now our total stocking cost on this one is TSC. So we are using among the formula sheets that have been given here on the total stocking. Due to safety stock, we are using this one. Okay, so we are simply saying it's our Q over 2, then P minus D over P, then by C plus D over Q on S. So this is annual setup cost. When they say annual setup, setup cost, and then annual carrying cost, the first part. Annual carrying cost for this one. Then here we are just going to have plus the safety stock SS multiplied by carrying cost. Safety stock units, SS is safety stock units by carrying cost per unit. So we have to account for, when we are doing stock taking, we are looking at what has been there, what we produced, annual setup. So here Q is 1610.15, it bounces back, then over 2, then we are going to have the P is 84, then minus a 30, which we found already, over 84. Then our C is 4.95, which we calculated as a carrying cost from the breakdown, plus the D is 7,500. Then over our Q is the same, 1610.15. Then by our S is 550, which is annual setup. Then plus our safety stock is 59.25. Then we multiply this one by carrying cost, which is 4.95. So 4.95. Then we are able to find our total stocking cost to mark the end of this question. So this should be done individually. 1610.15 divided by 2, okay, multiplied by 54 divided by 84 times 4.95 is 26. So the first one is 2561.86, and the other one is 75 divided by 1610.15 by 550. It is 1. This other one is 1.6. That is 2561. This will be almost the same answers. 0.87. Then plus due to safety. This is a self-reduced cost due to safety stock. Okay, so we are going to have our total cost in this case, which will be 59.25 multiplied by 4.95, which is giving us 293.2875. So after aggregating these ones, we are simply getting our total stocking cost as 5417.003. So this marks the end of this question to do with the production model on the inventory management. This question is a very common question that the examiner would give. So we have gotten the rotor point was 419.25, and then the other ones we are simply give self was 59.25. Those are in units. These are units or copies. Well, these are units. It's not your cost. These are units. And then we have the to stock. We have that one. Holding cost is that amount. And then we have gotten 5417.02 or 03. This is the total stocking cost. We have this one, and that one. So this is just the breakdown of holding cost, which is the same as carrying cost. So carrying cost, since we are in production, this is ordering cost, but it's called annual setup cost for production. So this is annual setup cost. All right, so this marks the end of this this question for inventory management. This question also came from the pamphlet. All right, so you can end here for now. So what is important is just to go through this breakdown of the annual production, annual demand, and the carrying cost is always the percentage of unit price. So it's just a matter of going through this question. So we'll now get into another question from the assignment, which is called material requirement planning in the shortest possible time.